Hello and welcome to Mathematical Coaching Center, and today we are going to discuss what are the different kind of angle that we come across while learning basic geometry, like adjacent angle, alternate angle, corresponding angles, vertically opposite angles, and other angles like acute angle, obtuse angle, and so on. But before we start, my name is Umang Khawas, and if you have any problem learning mathematics, then consider subscribing this channel. You can also connect me through other social sites like Facebook and Instagram. So let's begin our lesson with the first angle, that is the acute angle. The measurement of the acute angle should be between 0 to 90. So it should not be 90 also, it should not be 0 also. So this 0 and 90 is not included in the acute angle. So if the angle is equal to 0, then it is known as 0 angle, and if it is equal to 90, it is known as right angle. So the acute angle must lie in between 0 to 90. So it will be something like this. It should lie in between this. Okay, 0 to 90. So this is 0 and this is 90. It should lie in between, somewhere in between this. Suppose there's a line like this, and if we get an angle like this, so this is an acute angle. So this is an acute angle. So it should lie between 0 to 90. Next is the right angle itself. The measurement of the right angle must be equal to 90 degree. It should be exactly equal to 90 degree. So this is how a right angle looks like. Okay, this is a right angle. Now when we see two perpendicular lines like AB and CD are perpendicular to one another, at this point of time we see a right angle. Okay, so here AB is perpendicular to, here AB, this line AB is perpendicular to CD, this line is CD, so it is perpendicular. That means then we get an angle, that is angle ABC is this angle, so this will be equal to 90 degree. This is 90 degree here. Okay, ABC is equal to 90 degree. And again onto the other side also, here onto this side also, this angle is also 90 degree. The angle EBD is also 90 degree. So very important thing, when two lines are perpendicular, then there will be two angles. Okay, one on this side, on the other side, both the angles will be equal to 90 degree. That is, both the angles will be a right angle. Next, the obtuse angle. The measurement of the obtuse angle must be greater than 90 and must be less than 180 degree. So here also the 90 and 180 degree is not included. Okay, if an angle is equal to 90, then it is right angle, and if an angle is equal to 180, then it is a straight angle. So it should lie in between 90 to 180 degree. So it should lie somewhere in between 90 to 180. So this is the angle that is obtuse. So this is 90, till here it is 90, from here to here it is 90, and from here to here it is 180. So it should not exceed 180 also, it should not exceed 180, it should not be less than 90 also. So it should be from here to here, somewhere here. Okay, so this is an obtuse angle. So this is an obtuse angle here. So this is an obtuse angle. So this is how an obtuse angle looks like. Next is the straight angle. The measurement, as we already seen in this previous angle, that it should be equal to 180 degree. So this is a straight angle. So as the name suggests, straight, so it looks like a straight line also. It is a straight line, and the angle that is formed here is 180 degree. The measurement will be equal to 180 degree. So this kind of angle is known as straight angle. So next is the reflex angle. The measurement should be in between 180 to 360 degree. It should be between 180 degree to 360 degree. It should be more than 180, it should be less than 360. So here also 180 degree is not included and 360 is also not included. So if it is equal to 180, it is a straight angle, and if it is 360, it is a complete angle. So it should lie in between 180 to 360, somewhere here below the line. Okay, so this angle that we get here is the reflex angle. This is the reflex angle. Okay, so now let's see if there is an angle ABC. If there are two lines AB and BC, so one angle is formed on this outer side. Okay, this actually is a reflex angle. This is a reflex angle. Okay, so the angle there is a reflex angle, and it is written as REF, that is the reflex ABC. So we do not write it to be ABC. Why? Because if we write ABC, it is understood as this angle here, ABC. Okay, so normally what we write is a representation of an acute angle or a right angle or an obtuse angle. Okay, but if it is more than 180, that means we must write in this way. That means REF should be there, reflex should be there. So otherwise, if we don't write REF, there will be a confusion regarding this two angle, either this angle or this angle, which angle to consider as ABC. So if we write only ABC, that means that is an angle which can either be acute, obtuse or right angle. But if it is reflex, written as reflex ABC, that means its measurement will always be greater than 180 degree. Next, so now let's go on to adjacent angle. Now this angle that we see here in between the lines AB and BC, this angle is named as angle ABC. Okay, now if there's another line BD and an angle is formed onto this side, that angle is named as angle ABD. Now here we see that this line AB is common to both. Okay, this line is common to both. That means if that is the case, that means the two angles are known as adjacent angle. Okay, if we have a common hand, if we have a common line of two angles, okay, then these two angles are known as adjacent angles. These two angles are known as adjacent angles. Next is the vertically opposite angle. Okay, so here there are two lines AB and CD are two lines which is intersecting at a point O. This point, the point of intersection is O. The point of intersection here is O. Now we have four corners in which an angle can be formed. It can be either here, it can be either here or here. There are four angles, that four corners in which the angle can be formed. Now this angle, that is angle AOC and BOD, that is AOC and BOD. This kind of angle which is opposite to one another is known as vertically opposite angle, and they are always equal. Vertically opposite angles are always equal. They are vertically opposite angle and they are always equal. So not only this angle, but we can also get an angle here and here. So this angle is AOD and BOC. This is also vertically opposite angle and they are also equal. So AOD and BOC are also vertically opposite angle and which are also equal. So we have two pairs of vertically opposite angles when two lines AB and CD intersect at a point O. So what is a vertically opposite angle? They are pair of angles which are always equal, situated on the opposite side. So this should be situated on the opposite side. So this should be the opposite side. See, it is just opposite to one another. So this is opposite to this. Okay, so this should be opposite to one another. Next, suppose there is a line AB and CD. It may be parallel and it may not be parallel. Okay, there are two lines AB and CD, and there is a line PQ which intersects this two line AB at the point Z and CD at a point H. So this point is G and this point is H. So they are intersecting at a point G and H. Then this line PQ is known as transversal. This line PQ is known as transversal. Now what we see is The corresponding angles are the angles which occupies the same relative position, this line is very important here, which lines the occupies the same relative position at each intersection where a straight line crosses two other. So that means the angle must be at the point of intersection somewhere here and here. Okay, and it should occupy the same relative position. So what does it mean? That means if the angle, suppose let's consider this angle here, that is BGQ. We are taking angle BGQ. So this is above this line and onto the right hand side of the transversal. So it should be in this intersection. Same relative position means it should be above this line and onto the right hand side of the transversal. Okay, so angle here, that means this angle here is the corresponding angles. These two are the corresponding angles. So what is the name? BGQ and DHG. These are the two lines, two angles which are corresponding to one another. So next we have onto the left hand side of the transversal. Both are on the left hand side of transversal, and above this line, this is also above this line. Okay, so they are also corresponding angles. So that is AGQ and CHG, they are both corresponding angles. Next is on the right hand side, below the line and below the line. So the name is BGH and DHP, they are also corresponding angles. So next is below the line, this also below the line, this onto the left hand side, and again this also on the left hand side. So these are also corresponding angles. Angle AGH and angle CHP are again corresponding angles. So these are the corresponding angles that we have. Angle AGQ and CHG corresponding angle, angle BGQ and DHG are corresponding angle, angle BGH and DHP are corresponding angles, angle AGH and CHP are corresponding angles. They are corresponding angles. But the main important thing that we must see is what happens when the line AB and CD are parallel. So if the line AB and CD are parallel to one another, okay, at that time the corresponding angles will be equal. They will be equal. That is, AGQ will be equal to CHG, BGQ will be equal to DHG, BHGH will be equal to DHP, and AGH will be equal to CHP. So I have colored it with same colors. That means they are equal. These two are equal. Okay. So when it is parallel, okay, if it is parallel, then there will be the corresponding angles will be equal. So this is very important that we must remember. Next is with the same diagram here. AB and CD are straight lines and PQ is a transversal which intersect at a point G and H, and AB and CD may not be parallel. Now alternate angles are those angles which lies on the opposite side of the transversal line. This is on the opposite side of transversal line and the opposite relative side. It should be opposite relative side. So let's see what does this two thing mean, opposite sides of a transversal line and opposite relative side. Suppose if we take an angle here, okay, so this is below the line and on to the left side of the transversal. It is on the left side of the transversal below the line. So the other angle must be opposite, means it should be right side of the transversal and it is below here, so it should be above the line. So this is the angle that we get here. So these two are alternate angles. These two angles are alternate angles. So what are the name? AGH and DHG are the pairs of alternate angles. So next, here it is below the line and onto the right hand side, above the line and left side of transversal. See here, it is right, it is left, it is above, it is below. So opposite side of transversal line and opposite relative side. So these two are also alternate angles. So BGH and CHG are also alternate angle. Okay, next, BGQ and CHP are also alternate angles. Why? Because this is on the right side of transversal, so it should be left side of transversal. So this is above the line, so it should be below the line. Okay, so these are also alternate angles. And the last one is angle HQ and angle DHP. They are also alternate angles. So here also, what happens if AB is parallel to CD? What happens when AB is parallel to CD? The same thing here also, the alternate angles will be equal. This alternate angles will be equal. So this will be equal, this will also be equal, and this will also, this, all the pairs will be equal. That is only if AB is parallel to CD. So these are the different kind of angles that we come across while learning basic mathematics, and we tend to get confused amongst these angles. So I hope you understood the different types of angle. So before I leave, I would like to leave a question. The question is to identify all the vertically opposite angles in the given figure. So you need to identify all the vertically opposite angles in this figure. You can comment your answers in the comment section below. Thank you for watching and have a good day.